Welcome back, everybody. This video is a follow-up to last week's video where I basically covered how I destroyed my LightLeaf solar panels using Loctite during the install. And during that video, I presented some observations I made from some experiments, I guess you could say, I ran here in the lab. And as promised, the last part of this video will basically be all that footage about my little experiments. So if you want to watch that or you enjoy watching that kind of stuff, that will be at the end of this video. However, after those experiments and after putting out that first video, I just couldn't leave things well enough alone, and I kind of felt like there were some gaps in my knowledge or gaps in my understanding about exactly what was happening. So I decided I should get a little more information so that I could actually present something concrete instead of just kind of some assumptions based on some very limited experiments I was doing and what I was seeing. So I spent quite a few hours reading forums, trying to make sense of varying degrees of advanced chemistry I was seeing on the internet, and I felt like I was just getting more and more confused. So I actually decided to just go to the source, and I reached out to Loctite, and they actually got back to me. So a big thank you to Catherine from their technical information division for answering all the questions I had. Thank you so much for taking the time to do that. It really helped me out, and I hope to pass that knowledge on to all of you guys. So today, I'm just gonna rapid fire kind of share exactly what I found out so that I can kind of set the bar straight. There was some information I would find on forums that just wasn't correct. So I'm just gonna tell you exactly what I found out so that we can all kind of learn from this. Now, I'm not a chemist, and I'm sure some things I'm going to say are not phrased correctly or oversimplified, but I think the take-home messages I received are correct. And moving forward, depending on what you're building or what you're designing, hopefully some of this will just help you in that process. So let's get right into it. We're going to start out with just a couple really basic, kind of big umbrella items, and then we're going to dive into a couple kind of niche details that I thought were really fascinating as I looked into all of this. Number one, in the documentation for all the Loctites that I basically experimented with and that I commonly use, it says that it's an anaerobic process to have it cure. But what isn't mentioned, and I thought was really fascinating, is that metal also has to be present. During one of the experiments I ran early on, I tried to basically drill a hole in some plastic, drip some Loctite in that hole, and then cover both sides with plastic, effectively sealing off all the air, and I couldn't get that Loctite to cure. And now I understand why. It's because you need metal or metal ions present for the curing process to happen. I thought that was really interesting. Number two, maybe the most important thing that I took away from this in the long run is that Henkel actually has something called the Design Guide for Bonding Plastics, and it is a wealth of knowledge. It has just page after page about every single plastic you can imagine working with, and polycarbonate clearly says it is not suitable for working with these sorts of Loctites. That said, though, it includes tons of other information about what it does work well with, and I think that this document, I didn't know it existed, but I find it to be super helpful. All right, so let's get into the nitty gritty. Number three, my third point here, is that Catherine from Henkel, in an email, she wrote, why stress cracking happens is essentially because the anaerobic, which is like the Loctite, and the material have similar solubility. Since the anaerobic acts as a solvent, it essentially plasticizes / softens the plastic. The residual / internal stress in the plastic from its forming, in addition to the stress from external loads, overcomes the cohesive strength of the plastic, which causes the crack to form. Now, when I read this, I totally kind of light bulb moment. In the experiments I had done, I had noted that around the hole I had drilled with the screw placed through it, I would get these cracks forming, but when I actually would try to crack the plastic in between those cracks, it wasn't brittle. It still could take a spring punch and it wouldn't crack. So this really helps to kind of, in my mind, paint the picture of what's going on there at the molecular level to essentially cause these cracks to kind of radiate out from that center. Now, I also want to thank at the real Che-D. He found this nugget of information under Wikipedia because he actually looked up embrittlement, which is something I didn't even think to look up. And on Wikipedia, it says, polycarbonate provides a good example of solvent stress cracking. Numerous solvents have been shown to embrittle polycarbonate, benzene, toluene, acetone. Through a similar mechanism, the solvent diffuses into the bulk, swells the polymer, induces crystallization, and ultimately produces interface between ordered and disordered regions. So this knowledge was out there. I just didn't find it. So thanks again, the real Che-D, for finding that out. I hope I'm saying that name right. Moving on. So number four, what is this solvent then that's causing this solubility? It's actually methacrylate. And during a phone call with Catherine, this is the solvent that interacts with the plastic. I wanted to just state this outright. It's methacrylate. I found lots of conflicting information on forums about people speculating what that solvent might be, but that is it. And Doug Graham 5812, he hit the nail on the head with this one. He identified it as methacrylate, and yep, thanks Doug. That's good insight, and it was good to kind of confirm this after talking to Loctite. Number five, Contrary to what I found in my experiments, it is actually the uncured Loctite that will eat at the plastic. I got this graphic from Catherine about how Loctite will like pre-stress plastics when they're exposing them to different chemicals and like running these tests. And basically this pre-stressing will help these cracks and like these weaknesses develop. So on my tests, when I ran them, I couldn't get any failure by just dabbing the Loctite on. But I think this was because I wasn't straining the plastic at all. So I went back and actually re-ran that test by basically like pre-curving the plastic in the jaws of my vise. And sure enough, it like failed it amazingly. I was so excited to see this. So that was just like really great thing to learn. If you watch that first video, uncured Loctite doesn't seem to affect the polycarb. That's not true. Uncured Loctite is actually terrible for plastics. It is just the way I was testing it that wasn't presenting or like wasn't causing any of these results to happen. So that's like the biggest correction I'd like to make from that video, is that uncured Loctite is what is causing the problem. And then just to kind of close out why I think I did see the cracking in the contact samples, is essentially basically where I would tighten that bolt through the hole. It would basically be taking the place of like that strain test that they were doing. So the Loctite wasn't actually curing inside that hole because there was oxygen present in there. But what was happening is the tension from that bolt was essentially giving enough tension to the plastic, squeezing it enough to cause those cracks to form. So that is the behavior I was seeing. It had nothing to do with the plastic being in the presence of like some kind of off-gassing or anything. It was just the strain from that bolt head pressing it, causing those cracks to propagate. So that was, you know, there's a lot of corrections to be made. If you watch the footage at the end of this video, that's actually what's happening. And I did not know that, but now I do. It's great. I'm really glad this whole kind of experiment played out. So then number 6 though, according to Catherine, cured Loctite should be inert. It should not harm the plastic. But my take-home message from between talking to her and then some of the things I saw is I think it's really hard to guarantee that your Loctite is cured. You know, under the bolt heads or like between the nut and the bolt head in the plastic, I would still get wet Loctite there, you know, days after I had applied it. So as much as you could say once the Loctite is cured, it can be in contact with the plastic, I would say be really careful here. It seems like a pretty oddball application where you would actually have a place where you would need this kind of contact. But yeah, uncured Loctite should be inert, but I would say it's hard to guarantee it, so I still wouldn't use it around plastics, or, you know, it's a very, very weird application where I think that would matter. All right, so then just to finish off on all this, like what interaction is happening here, contrary to many forum posts that I saw and what I kind of theorized in my experiments, there is no fumes or off-gassing that is causing the plastic to become brittle. Catherine did tell me that like NASA, for example, will run these Loctites or thread lockers at like super high temperatures just to see what gases they release. But the chemicals that are being released during like everyday use, like for someone like me or like any sort of application that I think the common person would have, there's no gases being emitted or anything like that that is actually causing the plastic to become brittle. So that was kind of like a mythbuster moment. I had read several forum posts about people theorizing what gas it is, but there is no gas. It is actually just the liquid, that methacrylate, in the basically the liquid form of the Loctite. Moving on to number 8, if you read the TDS technical data sheet for all these Loctites, it will say not to use them in oxygen-rich environments. I asked Catherine about this because I wondered basically, since they need a lack of oxygen to cure, is it that like presenting lots of oxygen in the air, does that somehow affect it so that it can't cure once you put it into an anaerobic setting? And that's not what's happening at all. There's a different chemical reaction that happens if it's in the presence of like excess oxygen or ozone. So it's not related to this plastic Loctite interaction at all. Some other chemical reaction happens that's beyond the scope of my knowledge and my understanding. All right, and number 9, this is sort of a fun one. If I look at all the shrapnel of like all the experiments I've run here, I've definitely burned through some polycarb and used quite a bit of bolts for it. But one of the things I kept coming back to in the forums is that acetone actually reacted with polycarbonate quite dramatically. So I decided to kind of test that. So a couple things that we could look at is if you take some of these samples from like some of these shards, I guess you could say, from some of my experiments. First thing that I noticed is you can kind of glue polycarbonate together. If you wet one side and then put it on this plastic here, you can almost like actively watch it become milky in there, and essentially it will come to fuse these two pieces together. Not a gluing method I would recommend, but it's just pretty cool to me that you can kind of bond these two. It just melted so fast. Now that was pretty impressive until I basically realized, like, if you take any piece of polycarbonate, you take a rag that's wetted with some acetone, the reaction is just crazy like the ability, the velocity of this reaction. We can tension this piece here, we just dab it, and look at all those cracks that develop so fast. Oh man, I thought that this behavior was just, you know, the speed of this, it's just like seeing chemistry kind of happen in real time, I think is just always fascinating. Like we'll take this piece as well, got some tension on it. Magic trick, it almost feels like. The speed at which all these micro cracks appear, and this stuff just totally becomes, yeah, just brittle, incredibly brittle. I thought that that reaction was just really cool to kind of see play out right before your eyes. And then coming back to this piece, as you can see, it's milked over pretty well here. These pieces, they're actually fairly well stuck together. I mean, I'm going to be able to break this pretty easily, but I thought that was kind of a cool behavior that you can kind of glue these two pieces together by just dabbing a little acetone between there. So polycarbonate, plastics in general, and acetone, much more like a catastrophic reaction than the Loctite. I thought that was pretty exciting. So to round this all out, number 10, is I would just finish this out with that there are thread lockers that are designed to be used around plastics. Loctite makes Loctite 425, and I also have heard many good things about Vibratite VC6. It costs about $100 for a little bottle. So right now at this point, someone requested that I test that stuff out. Everything I've read says it works well. I just don't have any uses for it, and at this point I don't really want to blow $100 on thread locker. But yeah, the Vibratite VC6 also sounds good. I'm not going to test it, but there are options out there if you need to use thread lockers around plastics. So anyways, that's kind of a summary of what I learned. It was kind of good to get a little bit of like actual detail about this, actual knowledge instead of just speculation. There was quite a few things I said in the first video that just weren't correct. So now I am going to include all that experimental footage. If you want to watch that, please do. It's going to be long and boring, but it will probably kind of take you through what happened in my mind as I just watched all these things play out, and you might find that interesting. So once again, guys, thank you so much for watching. Thanks again to Catherine at Loctite. Yeah, it was eye-opening. It was really nice to learn all about this, and I hope you guys found this useful too. And whenever you're building something or designing something, you can use some of this knowledge to not screw things up like I screwed up my solar panels. So thanks, guys. So here's our experiment that's set up. We've got two blue thread lockers represented. The glue stick style, as I was saying, I like to use, it's the 248. 243 is actually what I used on my solar panel install. And then I did just one little test batch with a 290. This is a thread locker you can apply, like after a fastener is fastened, you can just kind of dab it in and it will actually wick itself into the threads. So that's the other thread locker I tested. So, you know, just to show, for control, what we've got right here, this is polycarb that's not contaminated. This stuff is insane. Like, you feel like this should just explode, and you can essentially do anything you want with it. If you try to take like a spring-loaded punch, you know, you can get it to kind of fatigue and crack after a couple bends, but it doesn't just become brittle. You know, even with like a spring punch here, you know, it doesn't crack, it just dents. So I'll actually show some video. I did the same thing earlier with some acrylic, and that stuff just shatters, but polycarbonate, good stuff. So you see here after a couple bends, it does split, but it's not brittle. It doesn't form any cracks. So the various tests we've got is I've just got, first on the side here, oops, whoops. This is just a little bit of dab of that glue stick stuff, the 248, and then I've got some 243. There's no contact between the actual thread locker and the plastic. It's just kind of hovering above there, so that's kind of first test. Then here I've got NC for no contact. I essentially made sure to install these bolts, not touching the thread locker to the plastic, but it is hopefully curing in there now that it's, you know, cinched down a little bit. Then I've just got a couple panels over here. These are essentially direct thread locker just kind of smeared over the plastic, and then the glue stick one over here. We'll see what happens to those. Then I've got for the C, the two samples of C, I've got contact. I made sure the thread locker actually touched the plastic as I was fastening these down. Got the 248 and the 243. And then I've just got the last one, which is that 290, that penetrating. I just hand tighten this bolt down, and then I just let that thread locker kind of wick in there. So we'll come back and we'll see, you know, with like a bend test. One last thing, I've got two coupling nuts. One I packed in here with the 243 and one with the 248. And I'm going to let these just kind of cure for a while. And then once they're cured, you know, we got a little bit of wet. I'll try to get any what looks like uncured Loctite off of this. We're going to put it through a couple more sheets of polycarb and see if the cured Loctite has any negative effect as well. This would be an application like maybe if you got a bolt that already had some thread locker pre-applied that looks kind of cured. So yeah, just curious if that will make things more brittle as well. All right. It's been about 2.5 hours since this experiment started. The proximity samples, I don't know, no reaction that can be spotted. On the no contact installation, this one does have a tiny little crack. Not sure if you can see that. It's right here in this bottom corner and the light catches it. That's the no contact 243. Tiny little reaction there. These, I can't pick out anything going on, any kind of crack action. That little mark there, that's a scuff on the back side. However, the contact ones, the 243, big crack there. Yeah, so this is just what we saw in the solar panels. This one might actually crack itself before the morning. We'll see if it continues to propagate. And then the contact 248 as well, just radial cracking all around. So yeah, polycarbonate, Loctite, this is turning out to be really a catastrophic kind of interaction. That's, you know, just, I'm not sure, cool to see, but at the same time, crazy that like I couldn't find this published anywhere on the internet, or like not very readable knowledge. So, and then the 290 at this point, no, nothing to be seen here. So the solar panel install has been going like kind of a cluster. So anyways, it's actually been closer to 30 hours, but I think we're just going to kind of look at everything that happened. Just for refreshing, this is untreated or uncontaminated polycarbonate. You can see, you know, about its bending force. On the first sample made, we make a first bend, but you know, even when it does start to break apart here at the seam, it doesn't actually crack. It just kind of, you know, it's not like a rupturing crack, like a brittle crack. It's just like the material fails, but you know, no like shatter effect or anything. So that's, you know, regular polycarbonate. So let's go through our samples. We'll start with this one that hung out above a puddle of this 243, which is actually what I used on my solar panels. I don't think it contaminated at all. It does have a weird line here, huh? So let's see if we've got any brittleness there. No, looks pretty good. So being in proximity to that, you know, we've got that little puddle over here, essentially hung out above this puddle the whole time. Doesn't seem to have had any effect on it. So I'm going to guess that the 248, which is also the blue Loctite, but the glue stick form, I'm going to guess that this is going to kind of behave the same way. Let's see. Yeah, not brittle, makes the bends, fails just like the uncontaminated polycarbonate. Okay, so then we'll move on to this, which would be like a direct contact. As you see, I've smeared the Loctite on the string here. Damn, I wish this would fucking focus. Come on, you bitch. Oh my God, seriously. There we go. All right, so that is direct contact, but did not cure, right? It's been open to the air. It does look like it's dried in some areas, but let's see what it does. Cool. So it has not become brittle either. And that is, you know, with the Loctite on there, but not allowing it to cure. So that's interesting. So it is something about the curing process that makes this thing. There we go. Yeah, so it's holding up well. So I'm going to guess that that was the 243. So I'm going to guess that this, which is the 248, as you see, this is actually dried quite a bit from when we first applied it. I'm going to guess this is also not very brittle yet. Oh, there we go. Doing quite well. It did maybe give up a slightly earlier, but it's not like shattering or anything. So anyways, that is the 248. Okay, so this, then we've got the no contact 248. I don't see any actual cracks here. As we remember, the threads here had Loctite on them, but I tried to make sure they didn't contact the plastic as I was tightening this down. So let's see if we remove this screw, what kind of behavior we get. It's funny, I actually don't have a whole lot of Loctite on that thread, but let's see if we got any kind of brittle kind of reaction. No, this one's doing just fine. Okay, so no contact, 248, which is the glue stick. Looks to be good. This one that I also tried to do no contact, this is the 243. As you can see, there is a tiny little crack there. The light catches it right. So I'm gonna guess this is gonna probably be a little more brittle. Let's see what it does. Oh, hold on, we need to actually get a wrench for the other end of it. So there's a chance that that 248, there just wasn't very much thread locker in there. This one seems to have made a much better bond just based on the fact that it was, took had quite a bit more resistance to get this thing unfastened. All right. All right, so when you look up close here, we can see that, come on, buddy. You can see that radial crack extends all the way to the inside there. And let's see. Crazy, even though it has that crack, the behavior of that area doesn't seem any more brittle. Interesting. So obviously we've got a crack, so I do feel like it's got some sort of weakening, but yeah, still quite good. Interesting. All right, then we'll move on to the, let's just do this 290 as well. This is the thread locker that, like, after you've got the fastener attached, you can kind of dribble some in the little gap here and it will wick in. Might also be called penetrating thread locker. So if we undo this bolt, oh, that's quite tight. Oh my gosh. Oh. Huh. Well, that shit really gripped. I don't know if I can do it right now. Holy Jesus. All right, we're gonna come back to that one. I might have to go get a power tool or something. One sec. All right, take two. Man, this green thread locker, I didn't know it was supposed to be this strong. There we go. Damn, that was quite the bond strength. Okay, so in terms of actual crackage, I'm not seeing any signs of a crack there. So, and then I'm gonna guess it's just not gonna be brittle either. Yeah, holding up fine. All right, so that brings us to the two that have like obvious problems. Here is the 248, radial cracking all around. I kind of assumed that this would just become like brittle, but it almost seems like the cracks form, but the material, the cracks obviously have hurt the integrity of it, but it seems like the stuff's actually not nearly as like brittle in the uncracked parts as I expected. Okay, so I think first I'm just going to kind of do this once you focus. Yeah, crazy. It's actually not that brittle, even though it is like clearly got these just cracks shooting all the way out. Man, I wish it was focused. Cool, so let's see what happens when we bend it. Oh yeah, it broke way easier. It's probably just down a couple of those cracks. So, fuck this goddamn focus. So anyways, that's, yeah, it didn't even make one bend. But, so definitely, yeah, that's with the 248. And then the worst one is this 243. It actually has less cracks running out. But as you can see, this one actually goes all the way to the edge, and you can actually feel the little gap there. Like this whole triangle has kind of, seems like it expanded out or something. So yeah, you can actually do that with it. All right, so let's undo this, and for the sake of consistency, just flex it. Oh, that's interesting. Actually, the threads are like, obviously when the nut comes up, it's not, this little part, didn't have any, the nut wasn't against it. It actually didn't seem to cure in there fully. But regardless, it did cause it to do that. So I'm not sure. Sure, we'll just flex it. Yeah, so that other side still was pretty good, but clearly we had some just totally catastrophic cracks. So this brings me to an idea. I think I'm just going to do one last test, which is I'm just going to drill a tiny hole in here, and I'm going to put clear-sided tape on both sides, basically trying to like fill that whole gap, and maybe just take a little time lapse to see if we can see those cracks spreading. So that's going to be the plan right now. Okay. Maybe we'll try to get a little backdrop here so we can maybe see things better. Anyways, we got the tape covering that hole. We're just going to go ahead and kind of pour a bunch of Loctite in there. All right, now we'll seal it up. Okay, and let's see what happens here. Well, this is interesting. It kind of like forced its way into an air bubble here. So I wonder if this stuff is doing some kind of off-gassing as it cures, because as we saw there, yeah, it did not want to stay sealed. Yeah, so interesting. Doesn't look like we've got any cracking going on or anything. Yeah. So maybe what we'll actually do is refill this, put the tape over, and then actually just like clamp it for a bit. So we won't be able to see it actually happening then, but it will be, maybe it will force some kind of reactions. I think that's going to be the new plan. Okay. All right, well, we'll let that sit for like a half hour and then we'll see what it's doing. So it's been, I'm not sure, 30, 40 minutes here. So let's see if we could force this to basically start that cure process in the absence of air. And does not look like it. Somehow we squeezed it out. Maybe through this crack here. But yeah, it does not want to have any sort of volatile reaction with just this. It looks like, here, let me get that out of there. Yeah, doesn't look, oh wait, no cracking. Looks good. I doubt it's brittle at all. Doesn't seem like it started to cure at all. So that's interesting. I don't know if it actually needs metal to start the curing process. So kind of fascinating. So that last little experiment there didn't really produce any meaningful results. So that's, I think, the conclusion to the science experiment portion of this video. I think there's some kind of weird relationship going on. Actually, crap. All right, guys. I thought that was the end of my science experiment. I did quickly forget to actually take these apart, which are those nuts that I had pre-cured essentially and then put on here. I'm gonna guess that there's gonna be essentially no reaction here, but let's see. So we got this first one. We'll unscrew that. This is from the 248, it looks like, which is the stick stuff. I'm gonna guess this is not brittle. Let's test it. No. Well, actually, we do have maybe. Huh. Let's see. Oh, wow. That is the first one to actually just like explode. Like if I bring this up close here, you can see it's got this just very light, almost like radial, just micro cracks. So fascinating. So this was pre-cured, as remember, but right around that little head area, when I tried to pre-cure it, there was a little Loctite left over there that wasn't cured. I tried to wipe it all off, but interesting. So this is 248. That is the stick product. This stuff, and then, yeah, let's see if the other stuff. This is the 243, the liquid, I believe. Let's see if it has any similar results. Yeah, it is the 243. Crazy. So that's the first one to be brittle. That almost was like a different plastic. Crazy. So that's funny. I almost thought these were going to be a complete waste. All right, so 243. This is the liquid stuff. And yeah, before I break it here, as you can see, kind of same thing. There's just some real micro cracking there. Fuck, focus. God damn it. So frustrating. There we go. You can see just a little bit of tiny radial crack in here. So let's see what happens. It's making a little noise. Oh, no, this one didn't crack. So anyways, some inconsistency here, but yeah. All right. Fuck, this focus thing is gonna kill me. All right, so that one didn't snap. Interesting. Yeah, so I guess I don't have any like firm conclusions to present. Some of my take homes is like, it seems like the polycarbonate that was like in proximity to the Loctite, no reaction, and then uncured Loctite on the polycarb, no reaction either. That said, when we tried to force a reaction with no metal, it didn't seem like the Loctite was actually curing. So some chemist or someone with better knowledge of this would know, do you need metal present for it to cure? I didn't think you did, but perhaps, yeah, I'm not sure. Or maybe I just didn't get a good air seal. Anyways, clearly though, like the bolts that are curing, that are screwed to the plastic, are causing it to become brittle. Like, you know, we had the snap action of the 243 and 248, or like we didn't have the snap action, but we had all that radial cracking around it. So that's basically, yeah, you know, bottom line is not a good idea to use Loctite with plastics, but that was just a fun experiment for me to see. And going forward, if I ever like drip some accidentally, but wipe it off in a timely manner, probably nothing to be concerned about. Anyways, now I'm going to finish up.